Let's go to first question, right? Two wires have lengths L1 and L2, carry equal currents. Two circular loops are made by these wires, and the ratio of their magnetic moments is 3:2. Then the ratio of length of the two wires is. Right, they're having what equal current, right? Two circular loops are made by these wires, and the ratio of their magnetic moment is then the ratio of these two having length carry equal currents, right? What is the equation for magnetic moment of a loop? Magnetic moment of loop, that is what single loop, it is what IA. Now I is constant, therefore M is proportional to A, therefore M1 by M2 is equal to A1 by A2. That A1, that is what pi R1 square, A2 that is what pi R2 square. Better to take it as R1 by R2 the whole square, pi would cancel. That will be the ratio between their magnetic moments. Now the wires are having lengths L1 and L2. A single wire bent in the form of circle, therefore length is equal to 2 pi r. Then r is equal to L by 2 pi, r proportional to L. Therefore M1 by M2 is equal to, instead of R1 we can take L1, instead of R2 we can take L2 whole square. Then M1 by M2 is equal to L1 by L2 whole square. Now magnetic moment, ratio of magnetic moment 3:2, right? Now 3:2 is equal to L1 by L2 all square. Then L1 by L2 is equal to what? Root 3:2. Yes. On taking the square root, root 3:2 is equal to what? L1 by L2. Now the choice is 3. First one answer is 3. Second question. Two small conducting spheres of equal radius have charges plus 10 microcoulomb and minus 20 microcoulomb respectively. Placed at distance r from each other experience a force F1. If they are brought in contact and separated to the same distance, they experience a force F2. The ratio of F1 to F2 is, yes, charge spheres. Then they behave like point charges. We can say the first one, F1 is equal to, if we are taking 1 by 4 pi epsilon 0 as K Q1 Q2 by R square, then it is 10 into 20 divided by R square. We are not changing the unit. That is why I am taking microcoulomb itself as the unit of charge. And I want the magnitude only. That's why I am not using that negative sign, right? Now, when they are kept in contact, similar spheres kept in contact, they share the charge equally. Kept in contact, they share the charge equally, right? Spheres of equal radius, right? Yes. They share the charge equally. That new charge is equal to Q1 plus Q2 by 2. That is 10 minus 20 divided by 2. That is what? Minus 5. Is it fine? Yes. Now the new force F2 is equal to K. Each and every one is having charge of 5. 5 into 5 divided by, they kept at the same distance R, right? Contact and separated to the same distance, right? Now what is the ratio between F1 and F2, right? Now F1 by F2 is equal to, in both of them K by R square, they are constant. Then F1, that is 10 into 20 divided by 5 into 5. That is, this is 2, right? This is 4, right? Now that is what? 8:1. That is 8:1. Now one more thing is that there is a negative sign, right? Now better to take the signs, right? Now one is attraction, this plus 10, and this is minus 10, that is attraction. Now both are minus 10, that is what? Repulsion. Now it is what? Minus, and here it is plus, it is what? Minus 8:1. Sign is there. Here it is what? Attraction. Here it is repulsion. Then the ratio should be having negative sign. If you know that, then no need to put signs. Now better to put the sign in each every equation, then we get the correct answer. That's a better one, I think. Yes, the best option is now minus 8:1. Right. Now even though we are not taking the sign, there is only one option having what? 8:1. Answer is 2. Now the third question. The distance between two coherent sources is 0.1 millimeter. The fringe width on the screen 1.2 meter away from the source is below. The wavelength of light will be. That is Young's double slit experiment, right? Two slit experiment. In two slit experiment, the fringe width, I am going to take the fringe width as beta. Beta is equal to lambda d by d. We have to find the wavelength, right? Now lambda is equal to beta small d divided by capital D. Now fringe width is 1.2, so this is 6 millimeter. Fringe width is 6 millimeter. This is 6 into 10 raised to minus 3. Small d, distance between two coherent sources 0.1 millimeter. That is 0.1 into 10 raised to minus 3. This is small d is the distance between the sources. Capital D is the distance from slit to screen, that is 1.2. Now this is what, if you are taking this as 0.6, it is what you can say, this is 5, right? 1.2, this is 5. Now this is 0.5 into 10 raised to minus 7. Yes, that is 5000 angstrom. 5000 angstrom. This is 5000 into 10 raised to minus 10. This much meters. Now it is 5000 angstrom. Answer is 2. Fourth question. In Young's double-slit experiment with two identical slits, when upper slit is covered with transparent sheet of mica, second order minima is observed above the center of the screen and second order maxima below it. Which of the following cannot be possible value of phase difference caused by the mica sheet? Look, we know that the path difference produced when a thin sheet is introduced, thin sheet of refracting index mu and thickness T introduced, the path difference is delta x. Delta x is what? Mu minus 1 into T. The path difference produces mu minus 1 into T. Now, the number of fringes shifted. Number of fringes shifted. Yes. When a single slit sheet is, when a transparent sheet is inserted in front of one of the slit, number of fringes shifted, that is equal to mu minus 1 T divided by lambda. Mu minus 1 T divided by lambda. Right, these are the two equations you remember, I think. Look, here it is given that the second order is minima is observed above the center of the screen. Because of introduction of this regime, second order is observed on the top, means bottom second order or second minima is transferred to this one, right? Then the the phase difference should be at least 4 into lambda by 2. That should be somewhat 2 lambda. Almost equal to 2 lambda or less than 2 lambda. Right? Therefore, the phase difference should be 2 into 2 pi, at least 4 pi. But look, 4 pi is somewhat near that. The only one choice that is less than this one is what? Pi by 3. 7 pi by 2 is less than that, but second order is just above. They already said that the path difference is what, just no. The second order shifted just above. Then the path difference should be at least 2 lambda or something like that. Therefore, the better option is what? Pi by 3, the first one. Yes. Okay. Now the fifth question. The length of the potentiometer wire is L. A cell of EMF E is balanced at a length L by 3 from the positive end of the wire. If the length of wire is increased by L by 2, at what distance will the small cell give a balance point? Right? What is the question? A cell of EMF is balanced at a length of L by 3 from the positive end of the wire. Right? If the length of wire is increased by L by 2, at what distance will the same cell give a balance point? Right? Yes. Look, EMF is equal to, first case, EMF is equal to voltage across L by 3. Voltage across L by 3. Yes. Voltage across L by 3. Right. Now, in the second case, the length of wire is increased. The length of potential wire is L. As the first one, the potential difference per unit length is V by L into what? L by 3. Now, yes, next case, it is what? The potential difference V divided by, the new length is what? L plus L by 2, that is 3L by 2. Now, L dash. Look, yes, on comparing these two equations, what do you get? V by 3, right? This would cancel like this, VVs. V by 3 is equal to what? VL dash 2VL dash divided by 3L. Right? This got VV got cancelled, this got cancelled, then L dash is equal to what? L by 2. That L dash is equal to what? L by 2, that's the right answer. Second one. Sixth question. Which of the following combination should be selected for better tuning of an LCS circuit used for communication? For better tuning, quality factor should be better. Yes. Quality factor is Q is equal to 1 by R root L by C. Look at the values of them. Each and everything. A choice 1 by R is 1 by 15. Root L by C, that is what? 3.5 divided by 30. I am not changing the unit because I just need to compare, right? Next one, B choice, it is what? 1 by 25 root 1.5 divided by 45. C choice, 1 by 20 root 1.5 divided by 35. D choice, 1 by 25 root 2.5 divided by 45. We need better quality factor. Now denominator is less, that is 1520. Denominator less and numerator is more, right? In this case, 1 by 20, this denominator is more, right? In all this case, denominator is more, this is more, right? This is also more. On comparing these two things, what? Here it is 35, here it is 20, therefore the better option is 1. Yes. Look, the value is greater for this one, the choice is A. Next, 7th question. A silver sphere, work function 4.6 liter, is suspended in vacuum chamber by an insulating thread. A travel rate of wavelength 0.2 micrometer strikes on the sphere. The maximum electric potential of the sphere will be. Right? We have to find maximum electric potential of the sphere, right? Now, work function is 4.6. What is the wavelength of insulate? 0.2 micrometer. 0.2 micrometer means what? That is 2000 angstrom, right? 2000 angstrom. Energy of this incident photon in electron volt is 12400 divided by 2000. It is 12.4 by 2, that is what you can say, 6.2 electron volt. Therefore, the maximum kinetic energy of emitted electron is incident energy minus work function, that is 6.2 minus, that is 4.6. That is only what? 1.6 electron volt. Therefore, the maximum stopping potential, the stopping potential is what? 1.6 volt. Therefore, the maximum potential of that sphere will be 1.6. If the potential reaches this 1.6 volt, then further electrons will not be emitted out, right? Yes. Now, the next case, 8th question. The ratio of wavelengths for 2 to 1 transition in lithium He plus H, right? In hydrogen like atoms, 1 by lambda is equal to Z square, Rydberg constant 1 by N1 square minus 1 by N2 square. In this case, these things are constant. Therefore, 1 by lambda proportional to Z square, lambda proportional to 1 by Z square, right? Now, the ratio is 1 by lithium, it is 3, right? Now, 1 by 3 square is 2. Helium, it is 2, right? That is 1 by 2 square is 2. Hydrogen, it is 1 by 1 square. Yes. To get the whole number, better to multiply it with 9 for 36, right? Now it is 36. 36 by 9. Only multiplying with 36, 36 by 9, 36 by 4, 36. Therefore, the ratio is 4 is to 9 is to 36. The ratio is 4 is to 9 is 36, 3. 9th one. Two metallic spheres of radii R1 and R2 are connected by thin wire. If Q1, Q2 are the charges on the two spheres, then Q1 by Q2 is equal to R1 by R2. After connecting them, their charges are, yes, their potential should be equal, right? Their potential should be equal. If 1 by 4 pi epsilon 0 is taken as K, now the potential KQ1 by R1 is equal to potential of second one, KQ1 by R1 is KQ2 by R2. Then Q1 by Q2 is equal to R1 by R2. That's answer 2. 10th question. Figure shows a square loop with side length A meter, resistance of wire ABC R ohm, and that of ADZ is 3 R ohm. Magnetic field at the center of the loop is, right? Better to do like this. First of all, what is the magnetic field due to a single straight wire of length L at a point having a distance L by 2 from the center? Yes, in this case, it's a finite length of wire. Therefore, the equation for magnetic field due to this finite length is mu 0 by 4 pi 2I by, it is I by R, that's a perpendicular distance. R is the perpendicular, here it is L by 2. Into sine theta 1 plus sine theta 2. What is theta 1 and theta 2? Draw a dotted line from the end, free end to this point. This is the point where we are going to find the magnetic field. Now this angle is theta 1, and from the other end, this angle is what? Theta 2. Now in this equation, substitute the values, mu 0 by 4 pi I. R is L by 2, that 2 goes up. Sine theta 1. It is exactly, what you can say, right angle triangle, isosceles triangle. Therefore it is what? Theta 1 and theta 2 are 45 degree. Sine 45 plus sine 45, that is 1 by root 2 plus 1 by root 2. Now it is mu 0 by 4 pi, or on cancelling this, mu 0 I by 2 pi L. This is 1 by root 2 plus 1 by root 2, 2 by root 2, 2 by root 2 is root 2, right? On cancelling this root 2 and 2, it is what? Mu 0 I by root 2 pi L. This is the magnetic field due to a single straight wire, right? It is mu 0 I divided by root 2 pi L, where L is the length. Now look. Now I am going to redraw the figure they gave. It's better to draw like this. Yes. They give the connection like this. Yes. You just keep your book what in slanting view, you can see like this is like given like that. Is what ABC. And this is what? ADC, right? Look, this current is what? 2 ampere, right? Now I am taking this current as I1, and this current will be 2 minus I1, or better take it as I, 2 minus I, right? What is the resistance of ABC R and that of ADC is 3R? We know that ABC and ADC are two wires connected in parallel. Then their voltage should be same. Voltage across ABC is I into its resistance R. Voltage across this ADC is, the current is 2 minus I and the resistance is 3R. This got cancelled. On taking this, no, before that we have to multiply, right? 6 minus 3I. On taking this one, 4I is equal to 6, therefore I is equal to what? 1.5 ampere. This is 1.5 ampere. Therefore this one is 2 minus I. How much is that? That is 0.5 ampere. 1.5 ampere and 0.5 ampere. Now look. Now this is what? One wire. The same thing what we took. Magnetic field this one, and due to this wire is also the same thing. Therefore magnetic field due to the upper wire, that is BABC. We can take it as what? BABC, right? The magnetic field due to upper segment is BABC. That is 2 into this one. That is then this 2 root 2 mu 0 I divided by pi L. Right? That I is what? 1.5. That is 1.5. That is, now this current is clockwise. Therefore magnetic field due to clockwise current at a point inside is into the plane. Or use your right hand thumb rule. This way the magnetic field is into the plane. That is into the plane. Now look, magnetic field due to ADC. That is also root 2 times this one, then root 2 mu 0. 2 times this one, that is mu 0. I is what? 0.5 divided by pi L. Is it fine? That is out of the plane. That is out of the plane. This is anti-clockwise. That is out of the plane. Therefore the net magnetic field will be, how much will be the net magnetic field? Net magnetic field will be BABC minus BADC. That is mu 0 root 2 mu 0 by pi L. 1.5 minus 0.5, it is what? Root 2 mu 0 by pi L. The choice should be like this, root 2 mu 0 by pi L. Yes, then the answer will be, instead of L, a figure shows square loop with side length A. Instead of L, they took it as A, right? Then it is root 2 mu 0 by pi A. Now one mistake we did, right? It is not 2 ampere. It is what? The current is what? 20 ampere. Then it is what? 15 and then this should be 15 and this is 5. 15 and 5. Now this is 15 and 5. 15, 5, that is 10. The answer is what? 10 root 2 mu 0 by pi L. Yes, instead of 2, they took us 10, no 20. Therefore, we have to multiply each and the current by 10 times, right? That's all. Then the answer is 10 root 2 mu 0 divided by pi A. Is it into the plane or out of plane? This is the bigger one. That is into the plane. When we are taking two vectors in opposite direction, effective vector should be in the direction of bigger one. This is the bigger one. 15 times. Therefore, it is into the plane. The choice is 1. 11th question. A balloon is moving upward with a uniform velocity 12 meter per second. When it is at a height of 81 meter, a body 2 kilogram mass is dropped from it. G is equal to 10 meter per second square. The body will reach the surface of Earth in. How much will be the answer? Yes. In that case, it is moving upwards from a height h. This h is equal to how much? H is equal to how much? That is 81 meter. 81 meter. Yes. From here, an object is thrown up. It is just like throwing up. It is not thrown up. Released. Balloon is moving with an upward velocity 12. At the moment of releasing, its initial velocity is 12. That's why it's taken like that. The body will reach the surface of Earth in time. We have to find the time. In this case, do you remember a shortcut equation? In this case, a shortcut equation, time taken is what? U by G plus root 2H by G plus U square by G square or U by G whole square, right? How much is UG? U by G, U is what? 12. 12 divided by 10, this is 1 by 2. 12 divided by 10, that is 1 by 2. This is also that 1 by 2 square plus 2 into H is what? 81 divided by, we can take it as 10, this is what? 1.2, this plus. It is what? 2 into 18 that is what? 16.2, 6.2 plus. It is 12 square is 140, it is 1.44, right? 1.44. It is almost equal to what you can say, 1.2 plus 16.2, that is 17.6 something, 17.6 something. That is almost equal to then root 17.6. How much will be that? It is somewhat near to 4.5, right? 4 square is 16 and 5 square is 25. It is somewhat near to 4, therefore better take it as 4.5 or near to 4.5, not near to 5, right? 4.5 plus 1.2, that is almost equal to 5.7. The better option is 5.4. 3 is the right answer. 3 is the right answer. 11 to 1, 3 is the right answer. Yes. 12th question. A particle located at x is equal to 0 at time t is equal to 0 starts moving along the positive x direction with velocity v that varies v as arrow text. A is positive constant. The displacement of the particle varies with time as. We need displacement tabulation, right? We need the displacement tabulation. Therefore, better write this one. V is equal to arrow text. Arrow text. We need displacement tabulation. Therefore, V we can take it as dx by dt. That is equal to arrow text. Then dx by root x. Rearranging this, we get a dt. On taking integration, dx by root x, better take it as what? X raised to 1 minus 1 by 2, right? That is equal to a dt, right? This is a dt, right? A dt integral. What is integral this one? X raised to 1 by 2 divided by 1 by 2, that is equal to at. Right? On squaring, you will get this constant, right? The on squaring x proportional to t square. The position is directly proportional to t square. Choice is 4, right? 13th question. A vehicle of 100 kg is moving with a velocity of 5 meter per second. To stop in 1 by 10 seconds, the required force in opposite direction is. What is stopping time equation? Stopping time, constant retardation, then stopping time is what? U by A. Yes. Now A is equal to U by T. It is moving with T 5. 1 by 10, it is 50 meter per second square. The force is what? Yes, A, right? A is 100 into 50. Answer is then 5000 Newton. 1. 14th question. The motion of a rocket based on the principle of conservation of linear momentum. It is simply based on conservation of linear momentum. Yes. Next, 15th one. A solid sphere of mass 10 kg and radius 0.5 meter rotates about tangent. The moment of inertia of the sphere is. Its tangent, what is the moment of inertia? It is 15. Diameter, it is 2 by 5 mr square. About the tangent, by using parallax theorem, we know that it is what? 7 by 5 mr square. 2 by 5 mr square plus mr square. Upon the choice is 2 by 5. M is 10. Radius is 0.5 square. Now it is what? 2 into 7, that is 14. 14 into 0.25, that is 14 by 4. How much is that? 7, that is 3.5. Answer is 3.53. 16. A spherical planet has a mass mp and diameter dp. Particle of mass m falling freely near the surface of this planet will experience an acceleration due to gravity with equal to. What is the equation for acceleration due to gravity? Acceleration due to gravity on the surface of planet. It is gm by r square. G capital M divided by capital R square. Here it is G planet divided by R is D by 2, right? D square divided by, that is 2 square is 4. 4 GMP divided by dP square, right? The first choice is what? Yes, 17. The escape velocity from the surface of Earth is V escape VES. A body of projected with a velocity 2 Vs with what constant velocity will it move in the planet space? Yes, can I say shortcut? If an object is thrown with a velocity u is equal to nve from the surface of Earth where n greater than 1, the velocity at infinity is equal to root n square minus 1 into v, right? Now here it is what? It is thrown with a velocity 2 times, it is root 2 square minus 1 into v. Answer is root 3ve. Yes. Yes, answer is what? Root 3. This is a shortcut equation for that. Better to remember like that. 18th one. Identify the false statement. Young's modulus of rubber is greater than that of steel. No. The stretching of a coil is determined by shear modulus. Exactly, that's correct. Young's modulus of rubber is less than that of steel. The first statement itself is false, right? Then elastomers do not obey Hooke's correct. Metals have large velocities. Yes, that's also correct, right? Yes. Next, 19, right? I think fourth one is also wrong, right? Metals have large values of Young's modulus than alloys. Not in all cases. Some cases maybe the steel is the highest. Yes, alloy, right? One is also wrong, right? Now 19th question. Blood flowing at the rate of 200 cm cube per second in a capillary of cross-section area 0.5 cm. The velocity of flow in millimeter per second is right. Volume per second. What is the equation for volume per second? We know that equation of continuity A1 V1 is equal to A2 V2. AV is the volume per second. Volume per second is AV. Yes. Now they given the volume per second as 200 centimeter cube per second, right? Better to convert it into meter cube, that is 200 into 10 raised to minus 2 cube, that is 200 raised to minus 6. That is area cross section. 0.5 meter square into V. Now V is equal to how much? 200 divided by 0.5, that is 400, that is 4 into 10 raised to minus 4 meter per second. 400 raised to minus 4 meter per second. In millimeter per second it is what? 0.4 millimeter per second, right? 0.4 into 10 raised to minus 3. Then the answer is 0.4 millimeter per second, right? Yes. Question number 20. Water falls from the tap down the streamline, then area increase or decrease. It is based on what? Again, equation of continuity. A1 V1 is equal to A2 V2. On going bottom, velocity increases, therefore area decreases. Area AV is a constant, area decreases. Above 1 is the answer. 21. Water is heated from 0 degrees Celsius to 10 degrees Celsius. Then its volume 0 to 10, we know that anomalous expansion. At 4 degree, the volume is what? Minimum. First decreases and then increases. The choice is 2. 22. 0.1 meter cube of water at 8 Celsius, which is 0.3 meter cube of water is the final temperature of the mixture is. Heat lost by hot body is equal to heat gained by cold body. That's a method or principle of mixtures, right? Yes. Heat lost by hot body. MC delta T is the equation, right? 0.1 meter cube of water, volume is a proportion to mass, then we can take it as what? Instead of MC delta T. Here C is A. Therefore, M1 delta T1 should be equal to M2 delta T2. M is proportion to volume, therefore V1 delta T1 is equal to V2 delta T2. V1 is how much? That is 0.1 meter cube. Delta T1, it is 80 minus the new temperature is T, I don't know what is it. Now V2, it is 0.3. And it is cold body, right? Then the new temperature T minus, it is 60. T minus 60. 0.1, 0.3, that is 3. 80 minus T is equal to 3T minus 180. Or taking this two side, this 180 plus 80, that is 260. That is equal to 40. T is equal to 260 by 4, that is 65 degrees Celsius.